Bruce Murray, author of Journey into Space, the first 30 years of space exploration. How do you think we've done in those 30 years?
Well, we've, like the classic phrase, the best of times and the worst of times. The best of times is partly what we're celebrating in July and in August. In July, we celebrated the 20th anniversary of Apollo, which was certainly the epitome of human exploration and humans in space. Nothing comes close to that. In August, we are being celebrated by Voyager 2 going by Neptune, which is an equally incredible feat, and perhaps in the long run of time equally significant, although certainly not in terms of immediacy. And so those are the high points. The low point, the Challenger when it blew up in January 28, 1986, bringing to an end a chapter of which the shuttle was going to provide cheap, easy, safe access to space. It has provided none of those. That was a false hope and a misled program, which we're now working out of.
What is Voyager?
Right, back to basics. Voyager is a robotic spacecraft, one of two, Voyager 1 and 2. They were commissioned by the Congress in 1972 and have been supported in one way or another by all the presidents and Congress since then. They are the most intelligent spacecraft ever built because they have to operate billions, as the famous parody goes, billions and billions of miles from Earth. Voyager 2 at Neptune is 3 billion miles from Earth. The radio waves traveling at the speed of light still take many hours to come back. And then if something were wrong, to decode that from the telemetry, send a command back, many hours. So with Voyager especially, for the first time we had to build robots that could analyze their own problems, figure out if their brains were defective, and switch to an alternate brain if they're getting the wrong answer, and take action. They're extraordinary.
Now, how far is Neptune away?
3 billion miles.
Why do we care what's on Neptune?
Why do we care? I think we care for the same reason people first looked through telescopes. We care what our setting is. We care because somehow we're a part of it, we've come from it, and somehow our opportunities and destinies are linked to it. We then discover, as one cares about things like the Arctic or the Antarctic in the 19th century, what could be more remote? Who could care what was there? Turns out it's very important for the world's weather and for its long-range climate, what happens there. So there turns out to be significance that's more relevant in the human time scale of your lifetime, mine, but it starts out with just curiosity and the urge to reach over, to go beyond the next hill, in this case, to the outermost limit of the solar system.
Why did you write this book?
I wrote it, I suppose, like most people, with several objectives, but personally I had it something I felt had to be said. I had a story to tell. I had a message to convey, but the only way I could convey it was in terms of my own experiences and those things I knew a lot about. So I had to tell, it's a memoir, I had to tell that story in order to tell the story of us, the United States of America, in this marvelous space endeavor for which we've had great achievements, great disappointments, maybe now possibility of starting up towards achievement again.
What's the Jet Propulsion Laboratory?
Jet Propulsion Laboratory is a center of NASA. It's a government-owned facility. The tables, chairs, and buildings. The people are all Caltech employees. It employs the California Institute of Technology, where I'm a professor. And it's one of a handful of these joint government laboratories that exist. The only one that NASA has. All the rest of the NASA centers are civil service. The Johns Hopkins Applied Physics Lab works with the Navy this way. The Lawrence Livermore Lab in Los Alamos work between the University of California and the Department of Energy. And the Lincoln Laboratory in Massachusetts is similarly between MIT and the Air Force. JPL has the distinction of being the only one that's working in civilian projects primarily.
Where's Caltech?
Caltech's in Pasadena, California, at the foot of the San Gabriel Mountains. It's where the Rose Parade happens every July 1st, every January 1st. And it is a small institution which has focused on science mainly, not even, its name is a little bit of a misnomer. It's not really an Institute of Technology, it's an Institute of Science. And in that environment, a few very unusual people flourished, and their spin-offs are legion, one of which is JPL. It's a spin-off from Theodore von Karman, who was there. The Mount Wilson Palomar Observatories are a spin-off from one of the founders of it.
Is this a picture of JPL?
On a clear day.
How often does this happen?
In the winter, very frequently. This time in the summer, it's not so often.
And what goes on here?
What goes on here in this very rather crowded collection of buildings now is the design of scientific instruments for space, the conception of spacecraft, the tests of them, the calculation of the trajectories, the people that are controlling Voyager 2 are sitting there, the antennae that transmit those commands are scattered around the Earth and are linked to it, but the brains are there. So the controlling brains and the design brains and the scientific individuals who are involved in interpreting the results focus in that particular place you saw.
How much money does it cost every year to keep JPL going?
Well, mercifully, I haven't had to worry about that since 1982.
Used to be director.
Yes, I was director from 76 to 82, and that problem of keeping it going was very challenging. It's not such a hard place to keep going in terms of getting money in. It's a very capable organization. There are always customers. It's a nonprofit. It works mainly for government-related things. Getting things in that are as uplifting and challenging as exploring the planets is quite another matter. That's been the challenge. When I was there in those days, it was 400 million. It's probably twice that now in terms of total money flowing through. A good third to, half of that flows out again to contractors in various forms. 5,000 people, another calibration.
How big is Caltech, and what kind of a school is it?
Caltech, in terms of faculty, is a little over 300 faculty, about 800 undergraduates, 1,000 graduate students. So it's a very, very small place by any standard in education.
State school?
No, fully private. We have a board of trustees, and we survive because of the philanthropy of the people in the country who believe that what we do in science and technology is worth it. There are a lot of government-supported research, as many universities have in them, but it's a fully private, independent, nonprofit, private, rather fiercely jealous of that. And there's been some tension, as you might imagine, between Caltech, this little high reputation, very concerned with scientific excellence and research institution, NASA, great big burgeoning organization, government dealing with applied things like space, and poor little middle-sized JPL, which is bigger than Caltech in terms of budget, in terms of total people, whose leadership is dual. So being the director of JPL leads to a lot of creative tension.
You came to Caltech in '60?
Yes, I came there. I'm a geologist by training, still my preferred planet, personally. When I finished that, I did a stint in the oil fields as a petroleum geologist. At that point, was called up to serve an ROTC Air Force tour that I'd signed up for but had never come due. That happened to take me up to a research base in Massachusetts, and the space program was starting. This was 1958. And so I said, after I finished my 2 years there, hey, this is too good a thing to miss, and ended up at Caltech as I'd been the oldest first lieutenant in the base in Massachusetts, and I became the oldest postdoctoral fellow at Caltech, and their first in space science.
Undergrad degree from?
MIT.
And PhD from Caltech?
No, MIT.
And both of them from MIT.
Right, yeah.
Over the years, 29 years at Caltech, you mentioned earlier, 5 years out as the director of JPL?
Yeah, 6 years, yeah.
6 years?
Well, yes, that's true. Although I'm still a faculty member at Caltech even then, because it's all the same paycheck, it's all the same people.
Okay.
In other words, all the people at JPL have Caltech paychecks. And technically it's simply a big division of Caltech.
Somewhere in this book, and I'll find it before the interview's over, is a picture of some famous men from Caltech. Harold Brown was the Secretary of Defense.
Right, the President of Caltech. Lee Dubridge, who was Nixon's science advisor, and Murph Goldberger, who famous scientist. All three were presidents at different times, and we managed to capture them at one of the Jupiter encounters at Voyager all together and got that picture. It's in here.
Is Caltech the only place of its kind in the United States?
In the world. In the sense that it's so small in terms of faculty and students, so successful in scientific research and stature, and somehow it managed to keep it going. Caltech was formed really in the 20s, when progress was spelled with a capital P, and JPL was formed because the government and the university had to get together because of World War II. And both those are anachronisms. You couldn't form either of them now.
What do you know about our mission in space that the average person doesn't? In other words, you undoubtedly talk about this a lot, and you hear people talking about what space means to them. What does it mean to the average person versus what it means to somebody that's steeped in this business like you are? What's the difference?
I come across this because when I speak and try to describe it, I have to deal with that. Or when I write and try to explain why craters on Mercury are significant. You seem like a simple topic. I think the difference between somebody who's chosen profession and avocation both is space exploration, and somebody who has to make his living doing something else but enjoys this, interested in it, reads about it, sees it on television, is those who read about it and see it on television, it's kind of served up like a carousel. It's a horse that comes around and then something else shows the next one. Airplane crash or some problem, maybe something good in biomedicine. Whereas if it's your life, then you see the connections. And this book is an attempt to portray those, the cause and effect. And naturally, somebody inside like this sees these connections and he's sometimes disappointed that even the best journalists seem to have a hard time connecting things. And if NASA doesn't do something, it was because Congress didn't appropriate the money. Often that wasn't the case. Often it was that NASA had a conflict of interest. And that's why it didn't get done. And that's one example, the role of humans, the role of robots, what's real, what isn't. And so the decision process is interesting, and to some extent, especially in civil space, which is intrinsically open, it's a mirror of ourselves, it's a mirror of our society, our times, our political process, the best and the worst. It's a mirror of our culture, our ability to focus on the future and to carry through or not. And since it's all open, and there's no territorial history to being in space, doesn't make any difference who your grandparents were, doesn't make any difference what language you speak, doesn't make any difference what your economic status is, there's no land use disputes going on. It's a perfectly neutral environment and very unforgiving, and doesn't cotton up to fantasy as Challenger demonstrated to us. We can have all the fantasies we want about ourselves and all the propaganda, look backwards, think how great we are, but if we don't do it properly in space, we will learn about it.
I found the picture I wanted to show the audience of the three Caltech folks, and Harold Brown, who was Secretary of Defense during Jimmy Carter's time.
And he was the person who was president of Caltech when I was selected to succeed Dr. William Pickering, who had headed the lab for about 20 years before me.
Gentleman in the middle is
Lee Dubridge, who still lives in Pasadena, a grand old man of American science.
On the far right
is Murph Goldberger, who is now at the Institute for Advanced Studies in Princeton and is the director there.
The one thing you mentioned, this gentleman served in the Democratic administration, this gentleman in a Republican administration. Are you all part scientists, part politicians? And you take, I mean, were these men, was one of them a Republican and one of them a Democrat? Or are they just scientists?
The statement is true. One was a Democrat and one was Republican. And that came naturally to them, I think. I don't think that was an affectation. It wasn't something they chose to further their careers. And the reason they were selected to serve in the administrations they were was because of those predilections. On the other hand, especially in a place like Caltech, but any place that is really focused on scientific research, there is only one currency, and that is research. Unfortunately, even when it comes to teaching, the currency is still research. And so one of the beauties for the luxuries, if you will, for a person like me to be at Caltech is there's no frauds. There's nobody there who's not what he says he is.
How do you know that?
Because it's small enough. There's only a little over 300 faculty. We know each other. We read each other's reviews. We know each other's students.
But if somebody's doing a bad job, aren't you all tenured?
Most of them are tenured, yeah. But the point I'm trying to get at is that the very nature of science is to be self-correcting. You're dealing, just like I said, with space, with externals. And so a place that's really focused on, like Caltech, which is probably more focused than any university in the world, in the sense that there's no medicine, there's no law, there's no business, there's some economics and social science, and behavioral biology, that's what we call humanities. There's very little engineering, really. It's mostly applied science. So that kind of place leads to a very special culture. And for someone who's privileged enough to be there, like I am, it's marvelous. You get some of the best graduate students in the world come flocking to come. On the other hand, you can get a very narrow view of life. You don't see a lot of what Washington, D.C. sees. You don't have to cope with the conflicts that are really going on. So it is an ivory tower to some extent in that regard.
What's the ratio of men to women?
It's about 15% women in the student body, even though we try very hard, in the undergraduate, somewhat higher in the graduate population. And that's not due to any lack of desire of Caltech to build up the women participation. It's due, I think, to, I would be careful, but my interpretation is that it reflects in part sort of a gender selection that takes place in junior high school, even, in high school. So that of what we are competing to get in is already narrowed. The faculty start out being all male. Give you some horror stories. And when the founder of Caltech, whose name was Millikan, great man, Nobel Prize winner, there were no women at all. There weren't even women secretaries. So we had a long ways to go, but we're getting there.
Picture here of a man that most people probably watching this will recognize. I'll let you tell us that one of them is you on the left, right, and the gentleman on the right. Why has he been so successful, at least in the public view, of being seen and heard from for the last 20, 30 years?
Well, Carl Sagan, who is the person pictured there and a very close personal friend, in fact, we were talking today, as a matter of fact, by telephone, is an extraordinary person in the following way that differentiates him from everybody else, including me. That he's not only a brilliant scientist, deeply committed to science, not just to his own science, to intellectual freedom and to all the structure that surrounds science, but he's also an extraordinary communicator. He's just unusual. He's off scale. His ability to write is virtually unmatched. There are a few other scientists who can write as well. His skill in use of television as a communication medium with integrity is certainly unmatched. His ability to deal with the Johnny Carson show or whatever and preserve some measure of his own dignity and be capable of talking about serious things in frivolous contexts is incredible. So, you know, like any celebrity, there will be detractors, and there are scientists who say anybody who's that good a communicator certainly can't be a good scientist. Well, that's not true. And there are, you know, so anybody with a celebrity will be a detractor, will have detractors, but he's quite extraordinary.
Who do you think are, and maybe this, I don't mean to set it up this way, just having mentioned it, but who do you think are the 4 or 5 most influential people in the history of space? The people that we would know in the modern age, in your 30 years that you write about?
It's a good question. It's harder to answer than you think because there's been an inheritance of ideas that go back a long time. And so
Maybe
Ray
even,
Bradbury has been a major contributor in many ways
why?
because of his writing about Mars. And he made it somehow seem like a place where people could be and got people interested in it. He, in turn, was in debt to H.G. Wells in The War of the World. And Orson Welles, spelled differently, in 1938 with radio characterizing a supposed invasion of Martians from H.G. Wells and scared the daylights out of everybody. So there, I'm just saying this is not a trivial answer. There is a cultural component to what's going on and has been, without which the technology would have never gone anywhere. So you have to have that. It has to be in the mind somehow and exciting. And in other words, you can't give a dry scientific lecture about what Mars is like to people to whom the word Mars has no significance. But beyond that, I think the most significant people for space in some ways are Wernher von Braun when he was working for the Germans, because he pioneered the development of the rocket technology. It was, of course, to destroy London that it was pioneered for, but I'm giving you a blunt answer. He then, of course, after the war, became settled in Alabama along with other German scientists and created an infrastructure which played a major role in going to the moon. So he certainly deserves a lot of recognition in that regard. You're going to have to give it to Sergei Korolev, the Soviet entrepreneur and technical manager who had been imprisoned by Stalin in one of the purges just before World War II. Was brought out during World War II to develop rocket artillery and flourished enough to get into long-range rockets, and his design bureau put up the first satellite, Sputnik, for the next satellites, and their rocket is the same design as what still launches Soviet cosmonauts into space. He was a great man, and considering the conditions under which he had to work, it's incredible. In terms of indigenous American help, JPL and its founders is in fact the oldest continuously existing rocket laboratory in the world, because Korolev's rocket work was disrupted because of Stalin and had to be reintroduced. Von Braun's obviously got broken up after World War II. And yet JPL, which started in 1940 with a $1,000 contract from the Army Signal Corps, continued all the way on through. But anyway, there have been many Americans. It's hard to pick out the one. It's be a funny answer, but I think the person who did more by his actions for creating the world of space that we now have today is John Kennedy. He did not do this out of space enthusiasm. He was certainly not technologically oriented personally, but he made the key political decision. And and in so doing unleashed the capability we had for real achievement and has set the standard and changed the balance of power in space, did many things. But it was his decision. It was just like, I mean, there comes a time where the buck stops at the president, as he used to have on his desk. That was the time.
Which politician has done the most to dampen progress in space?
I don't think any politician has been opposed to space, but the difference that will happen after Kennedy is that people looked upon this as a WPA, a constituency in Congress. They didn't seem to see it as a way for political benefit to themselves. Even Nixon, who put the shuttle going, it was in 1972, election year. They were worried about the vote in California, at least initially. It looked like a good deal to do, which any president would do. But there isn't any, once the Apollo thing was over himself and that he flourished in Kennedy's legacy, there's no evidence that he saw this as a way to further his own political ambitions or his own presidency. Carter came in, if anything, with a view that this was elitist and that the future was someplace else, even though he himself was deeply interested. And I talk about this in the book with some anecdotes. He knew more about space personally than any president and seemed to have less feel and more distrust for it politically than any president. And I think that was a failure on his part. Poor old Jerry Ford, of course, didn't really get much of a shot at this. Reagan came in, who has the same instinctive political feel for man in space and the rest, Unfortunately, he bought off on Star Wars. That was his space program. And the speech that Bush gave at the National Air and Space Museum on July 20th could have been Reagan's speech 8 years before.
Did you like what President Bush suggested? I mean, and what did you get out of it? What was
okay, let me, yeah, I liked it, and I was pleased, and perhaps a little surprised, having grown a little jaundiced about the political process in this period, because he took risk, and that this was not a safe thing to do. By doing the crucial thing that we've needed since 1972 and the end of the Apollo program, which was to say, here is where Americans in space should go, a destination. And it's an interesting, exciting possibility. He gave what the program must have to succeed and to keep from falling further into morass. But in so doing, he's creating the prospect of large expenditures in a time when the budget is the big issue, although the budget really is always the big issue in one form or another. He created a conflict for himself. And I think that's leadership, because he has to take that position in order to engender the Congress and all the other parts of our pluralistic political system to interact and to jockey around and to kind of find out, well, what do we really mean, a lunar base, or do you mean a lunar research station? And is it really going to be international? Are we going to have a high degree of cooperation, or is it really not that? All those discussions get fleshed out only because George Bush stood up on July 20th and said, I think we ought to go, and was vague about it, which I think was the right way to do it. Without that, we would go nowhere, and we'll continue to bog down to a point where it's really very uninteresting. With it, we have the chance for another age of achievement.
Our guest is Bruce Murray, and this is what his book looks like. Journey into Space, the First 30 Years of Space Exploration. And you're teaching at Caltech. How much time today do you spend in the classroom?
Well, first you have to say, how much does an average Caltech professor spend in the classroom? Which is not a whole lot, because we're a research university. Deal mostly with graduate students. I teach 3 courses a year, 4 sometimes. I really live there, though. That's where I make my income. That's where you find me, is at Caltech, not just teaching, but mostly working with graduate students in research. And that's the core of my activities. I'm very pleased. And when after JPL, of course, I had to decide what I wanted to do, and I tried some things and became the conclusion what I enjoy more than anything else in the world is teaching and working with graduate students doing research. That really is satisfying. I like to do things like this, which is a much broader endeavor, but I couldn't do that unless I had the intellectual stimulation and lifestyle that goes with being a professor at Caltech.
How did you write this book? Where did you write it?
Home, in my office at home. I had been thinking about this book for a long time, and while I was at JPL, I went into JPL full of hope that I could reverse the trend of backing away from space exploration, which had started in '72, and by the time I got through '76 was in full steam, and found I couldn't. I could ameliorate the effects somewhat and kind of dampen it and help cushion JPL, but I couldn't change that trend. That was pretty upsetting for somebody very focused on what he does. So I started making notes for this book. It was at that point called Vintage Years, and it ended up being 50 pages of notes and outline about the exciting times that I've been through, and of course these disappointments.
By the way, which one are you in this picture?
I'm the skinhead there. This is back in the '60s. That's Bob Layton, a professor at Caltech, who was the leader of the television team that got the first pictures of Mars. There's a few of them up here on the wall. I was a junior member of that team, and that was in 1965, almost the exact same time of year as now we were doing that. But anyway, as things seemed to be slipping away, I began to develop the concept of the book and all the notes and the concepts, the anecdotes, as a sanity saver.
What year?
It was 1980. Well, this came up to 81. I went there '76. By '81, things were really going very badly. Stockman was riding high. There were large-scale dislocations in the discretionary part of the civil budget, which is where NASA sat. And the shuttle was not part of that because it was perceived to have national security significance, which it really didn't have, but that's the way it was sold, and therefore shielded from it. So the consequence was that the rest of the science programs at NASA really were in very rough shape. Anyway, getting back to the book, that in that environment I wrote all this stuff out. I'd done a couple books for Harper, before Harper and Row. Had an editor there I admired very greatly, who unfortunately is now deceased, Frances Lindley. And so I sent her this stuff. She wrote back in a nice, gravelly voice style. Good idea, Bruce, but you're too angry. And she was right. So I put it away. And I just kept keeping notes and speeches and documents of various kinds. Did some other things. And it wasn't until the Challenger explosion in January of 1986 that I felt it was proper to try to describe this whole milieu of good things and mediocre things and cause and effect that civil space represented, because I thought the veils of fantasy which had surrounded ourselves had been ripped away. Now, whether I've got the most objective description of that or not, I mean, is another question. It's a very personal book. I wrote it as a memoir. That assures one thing, it's authentic. It's how I felt, the way I saw things there. That doesn't make it right. And I've done my best with a lot of people reading the manuscript and trying to check it, but it isn't an attempt to be a scholarly history. That's a different kind of book. It's an attempt to do something rather more large, which is try to really encompass cause and effect over a very large array of things. Domestic politics, competition with the Russians, technology, science, institutional rivalries, personal rivalries, public interest, the media, all those things are twisted together in this. And so I've attempted, and that's all I can say, to discuss those and by anecdote show their linkages, and then through that give my perception of how it works.
When did you finish it?
August of 1988, although I was working on the manuscript with corrections and so forth up until early spring of '89.
Why did you pick Norton?
I went back to Harper and Francis, and they didn't think that space was very popular anymore. They were wrong. She felt that very strongly, but that was it. And of the other publishers I was talking to, Norton was very interested and very thoughtful. Ed Barber, who is the editor that I worked with there, who is now on a more of an administrative position, is a really good guy. He sat, I don't know, for other writers. He took this stuff that I write, line for line, up in Connecticut on the weekends and holidays, working on it. And you can't pay that, you can't buy that kind of help. And so for anybody other than Tom Wolfe or some other really gifted natural writer, you need a lot of help, and especially if you're telling a story you feel very tense about and strong, you need somebody else who doesn't have a stake in this, but who's a really smart editor. Say, look, Bruce, who cares about that? Let's take it out. And there was a lot of that.
Why were you angry, and are you still angry?
I'm not, I hope I'm not as angry as I was. No, I'm certainly not as that. But writing the book helps that, too. I was angry because I believe very deeply in space exploration. I think it's one of the positive hallmarks of the 20th century. We've done it so well when we've done it well, that to see that slip away, to see us drift into mediocrity and into fantasy, was very difficult for me personally. And I'm fairly, I guess, one-dimensional person in that sense. That's the rocket that launched the Voyager 2 spacecraft. It's up there right now. The last flight of that rocket in 1977, the last flight the United States ever did, that's a Titan 3C Centaur. We will not have a replacement of that for another couple of years yet. That was the sort of thing that was a great mistake.
When did we launch Voyager 2?
We launched it August 1977. We launched Voyager September 1977 because they were in different paths to Jupiter, and Voyager 1 sped by and passed up Voyager 2. So even though it was launched second, it's Voyager 1.
What happens after it goes by Neptune?
Its path will be curved again because of the gravitational pull of Neptune as it goes around, and then heads on out towards other stars, it's already broken the gravitational attraction of the sun. So it's leaving this solar system forever. Nothing will stop it, as is Voyager 1 in a different direction, as are Pioneer 10 and 11, which were the precursor probes that were sent out. So there are 4 objects that the United States has put into space that are all working still with their nuclear-powered batteries and show signs of working for a very long time, that are probing out. You now back your telescope away from the Earth to where the sun is a little bright dot in the middle. They're going out in different directions and will begin, in the lifetime of people hearing this program, to detect the boundary between our sun and the interstellar medium, which has got a fancy name called the heliopause, and they should find it.
There's something, this is in the back under reference and notes that caught my attention. I suppose it's because we talk a lot about the media here and politics. But it's under the Chapter 4, Lost in Space. The fantasy, and this is about the shuttle, the fantasy of the shuttle as a cheap, safe, and effective means for Americans to enter the new frontier of space was so appealing to most audiences that there was simply no journalistic market for naysayers. Are you saying that the shuttle was so appealing to journalists that no one ever wrote the negative side of launching the shuttle?
That's right, and it wasn't until the Challenger explosion that the negative side was permissible. In fact, it became fashionable for a while, although that's going away. And I've worried a lot about that, because some of the things that became common knowledge afterwards, I don't mean O-rings, but the program, were available to journalists before. But they have to sell their story to an editor. And with a TV, it's hopeless, frankly, because their time constant so short that most TV so-called news, frankly, is pandering to the audience. Happy talk. C-SPAN is one of the exceptions to that, fortunately. But even in the print journal, even the New York Times, there wasn't much of an audience for it.
Let me read some more here.
Right.
These are your words, by the way.
Right. So I should agree with them.
No, but I mean,
Yeah,
the notes in the back. Most serious for an informed American opinion, the media were not committed enough to the public interest. The print media, and especially television, did little more than tell the public what it wanted to hear. In contrast, malfeasance and mediocrity in the Pentagon have always been considered newsworthy and thus are widely publicized. What do you think is at the heart of this, if you're right?
I think, this is hardly news, but it's true, is that our means of receiving information from the media is dominated to a larger extent than we would like by the economic necessity of selling advertising. That in turn to ratings. That in turn leads to popularity. And in terms of major networks, that leads to a corruption of the process of delivering it. The days of Ed Murrow have long been gone. This is not a value judgment, it's an observation. And I'm using the example here, which is important. This I do know about. That bad news about NASA didn't sell until '86, and it in fact permitted a overly generous and naive view and less critical view of the agency to go along much too long. We would have been better off to have had some muckraking, good and bad, get it out, and have to deal with these things more objectively. Similarly, I think the Pentagon, frankly, I'm not a Pentagon warrior, has had the opposite rap. It's any congressman can take a cheap shot anytime he wants about expensive toilet seats or whatever it is he's selling about the Pentagon. And that has clouded the whole debate about what is in that activity that's really important. How do we make judgments about it? And so I'm just linking these two, and both of them are kind of pandering to popular interest and appeal.
Let me read on. Congress, likewise, sensed the powerful political appeal of the shuttle's promise, and thus remained virtually mute in exercising its overview function. This next sentence, I want your reaction to. As a consequence, those American leaders, like Ronald Reagan, without either technical training or insightful staff, tended to acquire their views on the shuttle and on space from the general media. The President of the United States, Ronald Reagan, in your opinion, received what he thought, received his information from the general media, not from his staff?
No, he received reports from the staff, but his perception of what this was all about, whether it was a good thing or not, whether it was meritorious, what I suspect was derived from media. And I think that's true to a large extent for anybody who had not really been in the process for a very long time. I think it's true to a lesser extent in Congress, but the Congress individually do not have a lot of incentive to be naysayers in things that are politically popular.
What you're saying here, and it goes on here to say that for the same reason there are truly objective published sources about the shuttle program, there are few truly objective published sources about the shuttle program until January 28, 1986. The New York Times then focused its large and excellent staff on both news coverage and journalistic analysis of the shuttle and more generally of NASA. What you're saying, it seems, is that the New York Times has a tremendous amount of influence on setting the agenda.
I don't think they think so, because they've written editorial after editorial suggesting certain paths of action that NASA ignored. I think they certainly did a very good job, and badly needed, of investigative reporting, opinion, news detail, and so forth. This was neither an attempt to give a coup to the New York Times or criticism to other organizations. It was just simply describing. I was going to put a chapter in the book on this, as a matter of fact. There are a lot of things that didn't get done, and they end up as footnotes. I think that's a very important one, because, as I said, the media is a real part of this whole system. Our perceptions, including, I believe, the President of the United States, when Reagan was there, were colored by their perceptions of what this was about, which they derived from the media. And now, Kennedy, I don't think, had any more intrinsic interest in space than Reagan did, maybe less, but he had a very good staff. He had very, very able people around him, and the capacity to, get insightful information, alternative opinions very quickly. That's where Reagan had, Kennedy's science advisor was Jerry Wiesner, by the way, who opposed Apollo. His Secretary of Defense was McNamara. And there were a lot of other people. Reagan's science advisor was, at that time, unknown person from Los Alamos lab. I mean, the thing was totally different. And so I think that's been part of the problem.
If you had to make a choice, manned or unmanned, what would you take?
Well, I don't think that's a realistic choice. I know that's the conventional debate, and it seems strange since I've made my living as a researcher working with unmanned to say this, but they're both parts of the same process, because they both cost too much money to be justified by narrow constituency arguments. Unmanned exploration is not cheap either. It's not nearly as cheap as manned, but it's not cheap. So it only is going to happen if it produces a product and performs a function somehow for society that is desirable and widely appreciated. And that's exploration. If the society doesn't want to do manned exploration, it's probably not going to want to do very much unmanned exploration either. It's going to say, we've got all these problems on the Earth, we're going to focus here, and both go out. And so my view is that they're highly connected. Now, you can do either one well or poorly, and the coupling can be good or not so good. But the view that some scientists say, well, we could get those pictures of Mars, or we could get those samples back cheaper using robots, is irrelevant, because it still costs far too much money. The calibration point is the NSF budget over the years, the total budget for the National Science Foundation, and the budget for the part of NASA that does space science and applications have been roughly the same. I don't believe that any impartial group of scientists would say that the value to science, in their perspective, of the two kinds of funds are equal. So there has to be something else to that NASA money, which is exploration, technology, and other things. So I don't think I really believe that if the U.S. does continue on with human exploration, that will stimulate a burst of robotic exploration as it did under Apollo. If we don't, I think it'll continue to go down.
There's a picture in here, and actually I could hold it up almost any way.
That's right.
Inside, what is this? What are we looking at?
Well, this is the Apollo-Soyuz flight in 1975. This is Deke Slayton. This is Alexei Leonov, the Russian scientist, and this is the other American crewman. And this was...
Is that Tom Stafford?
Yeah, Tom Stafford.
I'm going to turn it upside down so
Right.
that our audience can see the...
That's right. And there's Leonov, and here's Stafford and Slayton upside down, standing on their heads in space. That's got a lot of significance because that came about because Brezhnev and Nixon got together in '72 at SALT I. Why'd they get together? Because Kennedy's Apollo decision had done such a tremendous demonstration of our power in space and our ability to do things that the Russians really felt it was their self-interest to come to some kind of accommodation. If we turned that Apollo focus loose on weapons, it would present them with an impossible challenge. That was important. This was a symbolic demonstration. It had little other value than that. Unfortunately, that was the end of it. That was the last time Americans and Soviet people have participated in any joint space operations.
What year was that?
It was 1975.
I'm sure you get this question all the time, but the Soviets and the Americans, what do we do best? What do they do best in space?
They've done a very good job of getting a reliable rocket system that relatively low cost because it's reproducible and don't keep changing all the time to deliver both humans and big payloads into orbit. I think they've done a lot of the same kinds of things we do. Their scientific instrumentation is not nearly so good. Their ability to exploit science is not nearly as good. Their ability to handle data, to get large amounts of data, is not nearly so good. But in a deeper way, there's a marvelous symbiosis that could take place and grow between the U.S. and the Soviet Union. They need each other. The Soviet program is at a crossroads now with perestroika. There's a lot of criticism internally in the Soviet Union about why we're spending all this money in space when we got all these problems on the Earth, and they really do have problems on Earth. My personal view is that the U.S. will not be able to sell to its, that is, the administration not be able to sell to the public and to the Congress a human exploration to return to the moon and go onto Mars without it being international. I think that the necessity and the desirability of that is enough to make it happen. I think simply that we ought to show how strong we are and plant the flag isn't going to work. So I think we need it. I think they need it. They have a policy. They want to cooperate very much. Gorbachev offered to Reagan publicly several times and was never even answered, incidentally, about the possibility of U.S.-Soviet collaboration going to Mars. So I think that the symbiosis, there's also some immediate things, though. For example, the Mir space station is up there empty. Soviets haven't even got anybody in it. We're talking about our space station and the need to spend large sums of money, among which we have to qualify humans for a long-duration flight eventually to Mars. Well, why not, in the meantime, work out and sign a piece of paper, that doesn't cost much, and have astronauts fly on Mir, along with cosmonauts, mixed crews, using American biomedical instrumentation equipment, and for a multi-year program to really not just demonstrate, but to figure out how to keep humans functional for that long flight. And maybe couple this with a joint flight of a year's duration Earth orbit later in the 90s. Now that's not going to cost either country very much money compared to what they're spending anyway. And we could find out whether we could work with them. We could get a piece of enabling knowledge that's crucial for going to Mars. And then set the stage for maybe the year 2000, if that seems feasible, to go ahead in a broader way. So there's some things we can do right now which our mindsets are still preventing us from seeing. And one of the purposes of the end of this book, a more positive vision, even though it is a bit visionary, I admit, was to remind people of this, that a lot of our limitations are imposed because the greatness of Apollo was that we did succeed, but it succeeded in a particular context that we now have to reevaluate and open up to look at it a little differently.
What do you personally want to accomplish before you hang it up?
Well, I'm working on Mars missions. That's an open-ended process. It goes on. It's like a monk working on illuminated manuscript. I'm doing my pages with the knowledge that that's important for the future. Beyond that, I would hope that we, as a people, do give a shot at listening for signals from other stars. That's probably the most important scientific question that could be answered, which is, are we alone? Interestingly enough, the idea of going back to the moon, the backside of the moon is the most radio quiet environment that we can have access to. All the radars we have, all the television stations we have, pumping radio energy out and contaminating our own. Satellites above are broadcasting down. The ionosphere itself is a radio emitter. And when one wants to listen to very faint signals, and particularly ones that are of artificial origin, our own signals from ourselves are the contamination. The backside of the moon is forever shielded from that because the moon is blocking all that out. So I would hope, I guess to answer your question, to see that that kind of program gets off in a substantial way.
You expect to see human beings on Mars?
The actuarial tables probably argue against it.
How long does it take to get there?
Only takes 9 months to get there, but I think we're talking about flights that are going to be in the era 2015 to 2020. And, you know, we're talking, the beauty of this thing and the liability, it's a long-term goal. It's stepwise. We work together to get there. The difficulty is that you have to keep that direction for a long time. So that's why these nearer-term goals, like joint qualification humans, a lunar observatory, robotic exploration of Mars, which we can do together with the Soviets in Western Europe and Japan, are really what's important now. We've got to put those in place. We've got to get people committed to those, and those that enable these more grandiose things later on.
The moon platform or research station or whatever, what do you call it?
Research stations.
Research station. Yeah. What would it look like, and how long would people stay there, and how soon do you expect that to happen?
In the order which you asked those questions, I think it would look like some little shack, dome with a power station and so forth, a hut. It would have TV monitors and joysticks inside and rovers and other kinds of articulated things outside, which would be actually setting up equipment, let's say this big observatory, and maintaining it. The humans would not occupy it permanently. There's no point to that. I think there's no necessity. But it would be reoccupiable. When they left, it would still be there. Probably stay for months at a time. When that might happen, it could happen as early, if you will, as the end of the century. My hope would be that it would be international, that it wouldn't be just a U.S. base with a Soviet base on the other side of the sea in tranquility, but that there would be mixed crews, shared functions. You obviously have to have a certain amount of national independence for risk protection. But I think the great value would be, as in Arctic exploration, around Arctic exploration now, it's a very international subject with a high degree of interaction, joint programs, and sometimes even shared transport.
From what you know of our experience with the Soviets, do we get along with them?
At the personal level, we get along very well. Until recently, of course, the KGB and the very closed society has been the obstacle. That's going away in a rush. So that the experiences I've had have been very satisfying at a personal level. I think the institutional problems of getting the tired Soviet bureaucracy, which is being torn apart and disassembled, to deal effectively intergovernmentally with a tired NASA, which never had Soviet-U.S. collaboration as part of its charter. That's tough. Now, and that's not going to change until the President of the United States says, we think that Soviet-U.S. collaboration in space is really important. If I can do something about it, that was all it would take. The previous people did not have that on their agenda in space.
Neptune, what do you expect? Are we going to see things?
We're already seeing them. It's showing up features. It may look like Jupiter from what we can tell. It's incredible. At the enormous distance away, the pictures taken at incredible ranges are already showing markings, rotation, atmospheric features starting up.
What's going to happen as we get, the closest to it? What major benefit are we going to get out of it?
Well, it's a rotating atmosphere planet. It's big. It's much bigger than the Earth. It has storms, undoubtedly, and things like this. So a chance to observe the weather, if you will, in a tremendous planetarium show where it comes closer and closer and you see it rotating and so forth. The exploration, by its very nature, defies prediction. If we knew exactly what we were going to find, it wouldn't be exploring. What you measure it is what's the gain in knowledge? What's the gain compared to where you were? That's incredible. Neptune's been a blue point of dot in the telescope up until now for most purposes, with a little bit of spectral information. But there's also some satellites, kind of strange ones. One of them, Triton, has got an atmosphere, and the atmosphere appears to be rich in nitrogen gas, the same gas that makes up most of our own atmosphere. There's only one other place, the Saturn's satellite Titan, is the only places that have nitrogen-rich atmospheres. So that's of great interest. So what are we going to learn from that? They've got some satellites in weird orbits that are suggestive of chaos. this marvelous new term that's come out in science to describe unstable dynamic phenomena. So we may learn about that. But most of all, I think we'll learn about ourselves, as T.S. Eliot said, by thinking of that Voyager out there 3 billion miles away from us who built it, and we're talking to it.
Bruce Murray has a PhD in geology from MIT. He has been the director of the JPL, the Jet Propulsion Laboratory at Caltech. He currently teaches at Caltech and continues to work on American space probes. Here is his book, Journey into Space, the First 30 Years of Space Exploration, published by Norton and in your bookstores. Thank you for joining us.
Thank you very much. Weather, and for its long-range climate, what happens there? So there turns out to be significance that's more relevant in the human time scale of your lifetime, mine, but it starts out with just curiosity and the urge to reach over, to go beyond the next hill, in this case, to the outermost limit of the solar system.
Why did you write this book?
I wrote it, I suppose, like most people, with several objectives, but personally I had something I felt had to be said. I had a story to tell. I had a message to convey, but the only way I could convey it was in terms of my own experiences and those things I knew a lot about. So I had to tell, it's a memoir, I had to tell that story in order to tell the story of us, the United States of America, in this marvelous space endeavor for which we've had great achievements, great disappointments, and maybe now possibility of starting up towards achievement again.
What's the Jet Propulsion Laboratory?
Jet Propulsion Laboratory is a center of NASA. It's a government-owned facility. The tables, chairs, and buildings. The people are all Caltech employees. It employs the California Institute of Technology, where I'm a professor. And it's one of a handful of these joint government laboratories that exist. The only one that NASA has. All the rest of the NASA centers are civil service. The Johns Hopkins, the tests of them, the calculation of the trajectories, the people that are controlling Voyager 2 are sitting there. The antennae that transmit those commands are scattered around the Earth and are linked to it, but the brains are there. So the controlling brains and the design brains and the scientific individuals who are involved in interpreting the results focus in that particular place you saw.
How much money does it cost every year to keep JPL going?
Well, mercifully, I haven't had to worry about that since 1982.
Used to be director.
Yes, I was director from 76 to 82, and that problem of keeping it going was very challenging. It's not such a hard place to keep going in terms of getting money in. It's a very capable organization. There are always customers. It's a nonprofit. It works mainly for government-related things. Getting things in that are as uplifting and challenging as exploring the planets is quite another matter. That's been the challenge. When I was there in those days, it was 400 million. It's probably twice that now in terms of total money flowing through. A good third to, half of that flows out again to contractors in various forms. 5,000 people, another calibration.
How big is Caltech and what kind of a school? Bruce Murray, author of Journey into Space, the First 30 Years of Space Exploration. How do you think we've done in those 30 years?
Well, we've, like the classic phrase, the best of times and the worst of times. The best of times is partly what we're celebrating in July and in August. In July, we celebrated the 20th anniversary of Apollo, which was certainly the epitome of human exploration and humans in space. Nothing comes close to that. In August, we are being celebrated by Voyager 2 going by Neptune, which is an equally incredible feat, and perhaps in the long run of time equally significant, although certainly not in terms of immediacy. And so those are the high points. The low point, the Challenger when it blew up in January 28, 1986, bringing to an end a chapter of which the shuttle was going to provide cheap, easy, safe access to space. It has provided none of those. That was a false hope and a misled program, which we're now working out of.
What is Voyager?
Right, back to basics. Voyager is a robotic spacecraft, one of two, Voyager 1 and 2. They were commissioned by the Congress in 1972. Applied Physics Lab works with the Navy this way. The Lawrence Livermore Lab in Los Alamos work between the University of California and the Department of Energy, and the Lincoln Laboratory in Massachusetts is similarly between MIT and the Air Force. JPL has the distinction of being the only one that's working in civilian projects primarily.
Where's Caltech?
Caltech's in Pasadena, California, the foot of the San Gabriel Mountains. It's where the Rose Parade happens every July 1st, excuse me, every January 1st. And it is a small institution which has focused on science mainly, not even, its name is a little bit of a misnomer. It's not really an Institute of Technology, Institute of Science. And in that environment, a few very unusual people flourished, and their spin-offs are legion, one of which is JPL. It's a spin-off from Theodore von Karman, who was there. The Mount Wilson Palomar Observatories are a spin-off from one of the founders of it.
Is this a picture of JPL?
On a clear day.
How often does this happen?
In the winter, very frequently. This time in the summer, it's not so often.
Now, what goes on here?
What goes on here in this very rather crowded collection of buildings now is the design of scientific instruments for space, the conception of spacecraft, and have been supported in one way or another by all the presidents and Congress since then. They are the most intelligent spacecraft ever built because they have to operate billions, as the famous parody goes, billions and billions of miles from Earth. Voyager 2 at Neptune is 3 billion miles from Earth. The radio waves traveling at the speed of light still take many hours to come back. And then if something were wrong, to decode that from the telemetry, send a command back, many hours. So with Voyager especially, for the first time we had to build robots that could analyze their own problems, figure out if their brains were defective, and switch to an alternate brain if they're getting the wrong answer, and take action. They're extraordinary.
Now, how far is Neptune away?
3 billion miles.
Why do we care what's on Neptune?
Why do we care? I think we care for the same reason people first looked through telescopes. We care what our setting is. We care because somehow we're a part of it, we've come from it, and somehow our opportunities and destinies are linked to it. We then discover, as one cares about things like the Arctic or the Antarctic in the 19th century, what could be more remote? Who could care what was there? Turns out it's very important for the world's